So let's look at an example here. And the example is I want to look at 238.92 uranium. So what you're going to find here is that uranium uses alpha decays to reach stability. So what happens here? So what we'll do here is that we want to start with the reaction equation. So if I look at the reaction equation, what do I mean by that? Well, we should start with uranium. So here's my copy of uranium. Okay, right there. And so when I write the details of uranium, look what I have. I have 238.92. And then what's it going to do? It's going to do an alpha decay. As a process of this, it has to emit an alpha. There we go. So I have 4, 2, helium. So what does that mean? That means it has to reduce 238 by 4. It has to reduce 92 by 2. So then that means I have an element that's now going to be 238, 92, but because helium carried away 4, I got to reduce the atomic mass by 4. Because helium carried 2 protons away, I got to reduce my number of protons. And so now this is my new daughter, right? So here's my alpha. Here's my daughter. By the way, an alpha particle is also a daughter, and then it emits energy. So then the question is, what is this element here? So then we ask, so if I write the details, let's write the details. If I look at the details, so then this becomes 4,2 helium plus, look at this, 234, 90 Y plus energy. So then our question is this. Which nuclei is this? Well, from the periodic table, we got to go to the element 90. So from the periodic table, we must look for atom 90. So if I go and I do that, look at this, I got to go look for 90. So here's 80. There's 90 right there. So that's thorium. So if I now go back to my sheet here, you could see here is that this element here is thorium. So now I have thorium. So what this tells me here is that the decay then looks like this here. It really says that I have 238.92 uranium. Again, then I have my alpha decay, and I'm going to get 234.90 thorium plus my alpha plus my energy. So this is what the decay tells me here. Guess what? Thorium is radioactive. So let's go look at this thing here. Just to show you that that we're seeing this here. Oh, I'm barely going to get the picture in. So let's go look at this thing. So remember what I said, these all move towards the black line of stability here. So I'm going to guess, look at uranium is 92. So let me go get uranium 92. So I'm going to guess that uranium 92 is going to be somewhere about right here. I'm going to come in here and I'm going to just kind of guess because this isn't scaled. So this is uranium. Now I need thorium. Well, thorium is closer to the black line of stability. So let's say that it's right here. And we're going to say that thorium here, that this is 90 here, and that this is thorium. And what you're seeing here is that look what it's doing here. What it's doing here is that uranium is doing what? You can see that uranium, so in this case here, so when I look at this, the uranium nuclei is moving towards the black line of stability. And because thorium, and since thorium is unstable, it too is more likely to decay via alpha again. So you'll see a series of decay chains as it goes down towards the line of stability.